So previously I talked about how water desalination could be a useful energy source in mining minerals and metals from it. Well, I want to talk about how we could do that and the uses of everything. This is from Stanford, and this is about the makeup of water that isn't water. Now you notice it's very low, total amounts, but in seawater, but we're getting rid of all the water already, most of it. Now let's say we take that salt and we get rid of the chloride. Chloride makes about, we get rid of the chloride, we get rid of the sulfur, we get rid of the bromine, and everything, fluorine, nitrate, nitrogen, and phosphate, and iodine, nitrate, all the stuff that is ammonia, organic phosphorus, and a bunch of other little things, because all this stuff we can get rid of it with electrolysis, where this negative charge thing goes out, or the carbon things or nitrogen stuff when we heat up to high temperature to do electrolysis. Those just come off as a gas. So you have gas because the high temperature breaks them apart. That would make the concentration from getting rid of all the water, which concentrates it all these chemicals a couple thousand times, to now getting rid of more than doubling concentration now until we get to all these useful ones. So let's go down the list. Sodium, it's useful, and magnesium, it's useful because we're starting to think about them as alternatives to lithium in batteries. Magnesium theoretically could hold more electricity than a lithium battery, but there's some problems with it that it's not very well chargeable and it's more reactive and stuff. Maybe we get rid of those problems. Sodium batteries have a lot of things that are better than lithium batteries, but they're heavier. They're a lot heavier, so they might not be good for cars and stuff, but maybe for places where you're storing electricity that's not moving, like the house or grid storage. Sulfur, which is one of the chemicals we split off, that's very useful for fertilizers and for a bunch of drugs and stuff. Now calcium, vital nutrient, a lot of other things. Potassium we're also looking for in batteries, like sodium to some extent, and also we're kind of looking at calcium. Bromine we can use in a little bit of plastics, we don't use in a lot of things. Bromine's even separated from the chlorine and stuff that comes off, and the sulfur in the one end. And bromine has a little bit, and sometimes people use it instead of chlorine for cleaning up water. Carbon, just we're not going to recycle here. Strontium has a bunch of niche uses for fireworks and stuff like that. Maybe we'll find some better uses. I don't know off the top of my head. Boron, though, has a ton of uses in everything from cleaning agents to pesticides. Doesn't mean this is a dangerous chemical. It's just if you combine it in some ways, you need a little bit of your body, but it's also the design fancy new cool electronics with boron in it that can store more power or act as faster transistors and maybe store information. It's also used in a lot of to make steel and a lot of metals harder and more temperature resistant. Now we get to silicon. Silicon is a big one. Silicon, you can see that silicon is super useful for making solar cells, computer chips and stuff. And even if solar cells are now using less and less silicon, computer chips are here to stay in electronics. Aluminum foil, but even batteries nowadays. And the nice thing about aluminum, potassium, and sodium and magnesium is that we could make a battery that has a mixture of all of them in the same battery, so you don't have to purify it as much. Perhaps. We developed to have one. Fluorine, another, like chlorine stuff will go with the chlorine and stuff, and it's used to make some plastics. Also, chlorine's been used to make some plastics, especially PVC, which is one of the, I think, the 6th most common plastic. Nitrogen and stuff will just boil off, so we can't really recycle that. Rubidium, Mostly used, the biggest use of rubidium is in some very expensive catalyst for making plastic, for making stuff, but it's not a widely one. Ruthenium is more used, even they're not very similar, but they both have RU in the name. So, but rubidium is used in some lasers. Lithium. Now we get to the high-tech, ultra high-tech battery, and lithium is very hard to mine and not the best for the environment. So getting lithium out of the water will be very good. Phosphorus will come off in the other end again, and phosphorus has use in making fertilizers. Some other uses are not as big in the food industry. Copper wires everywhere. One best conductors electricity and heat, and now it would also be useful for some brasses and bronzes, even though we don't use as much. Barium, not used that widely for a lot of things. It is rat poison, but it's not the most safest. Iodine comes on the opposite end with chlorine stuff, and it's used as a disinfectant in some cases, as a more mild one. This will just get destroyed in the process. Arsenic, not very useful, you want to get rid of that. Iron, very useful, but very small amount. Phosphorus, again, it gets out. Zinc is useful in supplements and making a bunch of, in some brasses and bronzes. Depends on what ones. Some of them don't have it. It's used in a bunch of other little thick metals that have to make a metal with a low melting point. And it's used in some batteries. Manganese is also now being used in some batteries. Lead. So lead is poisonous, but lead has been starting to be used in some solar cells. And it's really self-contained, so it could be a useful one. Same as with selenium, it can be used. Selenium is also an anti-dandruff one. Tin, we use it for a little bit of metals. Cesium is super expensive, and it can improve batteries, and tiny bit of it can improve batteries and solar cells a lot. A tiny bit of it, but people don't use it because it's so prohibitively expensive. Molybdenum, used this is where we start getting it's not very common. So you have to be careful, but the stuff is going to start going up, way up in price. Molybdenum is used in a very little bit to make a bunch of metals harder and stronger and more wear resistant. But too much makes it worse. Uranium, nuclear reactors, but it's not very much, but it's very expensive per amount. Gallium doesn't have much uses yet. It makes metals that you can make alloys with it that melt at extremely low temperatures of metals, which has some neat uses for like metals that fuses that fall apart quickly and easy to just melt when it's too much electricity. And they're starting to make certain electronics with it so that that switch on and on very fast, which can turn AC to DC better. Nickel, it's not going to beat nickel. Nickel is very cheap and it's very common, so it's not going to be that useful for nickel, but nickel is used in a lot of steels and metals and performance. Thorium is like uranium, but safer. You can't make nuclear bombs out of it, and nuclear waste is safer. Cerium, used in some stuff with radioactive stuff, not as much. Some smoke detectors, some cancer therapies. Not as much. Vanadium is used in some alloy, but it can be expensive. Vanadium is used to make some alloys better of metals, harden stuff in very trace amount. But again, at this low concentration, it's probably not that much worth it. Lithium, lithium, lithium and lithium are very useful in making magnets and catalytic converters and a bunch of other things, and they're really expensive right now, and China controls most of it, which causes a problem for the global supply. And also, everything is, if you can make your metals and stuff locally, so you don't have to worry about supply chains hundreds of miles away on the opposite globe that might get cut off from you, or politics or something. So it gives you some more independence. Mercury, very low concentration and not that useful comparatively. Silver, expensive, but low concentration. Silver is used in jewelry, of course, but it's also used it's one of the few things that's more conductive than copper in some cases, not always. and it can be made to use better wiring, and it can be more corrosion resistant. It's also has very good antimicrobial properties, and it can be very useful catalyst. Bismuth, I'm not too much familiar with use. You can make some low melting alloys with it, not as much as gallium. It's used in Pepto-Bismol. Some art projects, not too much. Cobalt, extremely useful. The mining practice is extremely bad, but it's pretty cheap now, and the concentration is pretty low here. But it's used in magnets and a lot of batteries. Gold, very expensive but low concentration. So if you can get gold, you could get maybe all these other ones, and it could work out. And gold is used in a lot of catalysts that are expensive, and it's used in a lot of wiring like silver stuff, and it has its own cons and stuff. Also, gold is one of the most malleable metals and ductiles, one of the most easy to bend and deform. Well, I hope you found this interesting. Please like and subscribe if you like the channel or like my other videos. Also, I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard. With your help, I think I can do it. Thank you very much. Goodbye.